Okay, so my name is Scott Walter, and I've been in the field of robotic simulation for about 4 decades now. And I started in the area of simulation back in the early 80s as part of my doctoral thesis when I was at Cornell. And when I left Cornell, myself and a couple other Cornellians got together and we formed a company called Deneb Robotics to look at the field of robot offline programming. So we understood the issues at that time of that robots could not program themselves, and we needed tools to be able to do it. And the tools to do it were online, which meant you had to have the real robot in the real factory floor, and a person had to go down there and take it out of production in order to do it. The idea of offline programming was to create a virtual world. And of course, at that time, the idea of a virtual world, the term didn't even exist. But basically, that's what it was, a 3D world that emulated what was going on the floor, and you would work in that 3D world while the real robot was still functioning, find out all the issues with it, maybe be able to do some things that you couldn't do on the real floor because you can get away with a lot of stuff in a virtual world that you can't in the physical world, and then get it to program. And so did that for quite a number of years, got involved in some arc welding projects with a shipbuilding company called Fincantieri. And from there, we get the insights of how to speed up robotic programming by making it parametric and making it templates that would allow you to sort of copy experience you get from one area to another and reuse and reuse and reuse. Deneb was eventually sold to Dassault Systems and then rebranded as Delmia. And in 1999, with some former Denebians, we got together and formed another company called Visual Components. In the past 20 years, we've been evolving the whole idea of robotic simulation, factory simulation. And of course, recently, one of our very good partners that, let's say, we've known each other for 3 decades or more. We decided to kind of combine our two companies together, the delphoy company, and bring in the experience that delphoy has brought along from the past, easily 20 years of understanding how do you program industrial robots. What's the most effective way? What are the brands that are most commonly used? What are the issues between going from a generic application to a particular branded application? What are the important applications that are out there? Because we can offline program a variety of applications, but it might be so niche that only one person needs it. So what does the broader market need? Well, there's welding, there's plasma cutting, there's grinding, there's surface preparation and painting. There's a variety of things like that that are used everywhere. So why not take that experience and make it available to the everyman person? So we used to be selling to very large corporations because they're the only ones that could maybe afford it or really had the need. But actually, the people who needed our product more than anyone else were the smaller companies. They just didn't either have the sophistication at the time or they couldn't afford it. Well, costs have come down. Computers are cheap. Software is getting cheaper. People are more experienced. They understand the 3D world because on the weekends, they're playing games and stuff like that. So they kind of understand that world right now. It's not something that's new for them. And now they get a product that is so easy to use, they become productive. And then the ROI is extremely rapid. So if you're a small company and you have a robot that's not working, this will probably be a way to be able to make that robot productive again. And if you're considering it and are concerned, well, how do I program it for my small batches? Well, this will be the thing that changes your mind to say, yes, we actually can go ahead and automate.
Fantastic. Thank you. Also really interesting. So it's an honor. So what would be the main challenges for the manufacturing industry at the moment that you think?
Oh, the main challenges for manufacturing industry is bringing costs down and improving quality at the same time. And the third one is the fact that they're kind of running into a labor shortage in some areas. So it's well known that we need a lot of people who have experience in arc welding. And if someone has a child and they don't know what they should do with their life or what would be a good area to go into, arc welding would be one of those. Now, it's physically demanding. It's a very tough environment. It pays pretty well. You'll be able to find a job very easily. But despite that fact, there are not enough out there. And it's been known for a while, how are we going to replace this aging population of welders that are disappearing and not being backfilled with a younger generation? The only way to do that is to start to bring in the robots to start doing those applications. So it will end up doing a couple of things. The automation will drive the cost of manufacture down. It will also increase the quality because every single weld will be done exactly the same way. A lot of times if you have a very skilled welder, it'll be almost like a work of art of what they're doing. If you have someone that's coming in that only has a few years of experience, their welds may not be quite as good. And we know if you have quality issues, that costs you a lot of money because you have to go back and figure out what it is. What can we do to improve that? So if you want to have consistency along the whole product line, you can do that. By bringing in automation, especially when you bring in software, you can capture the information about what makes that particular weld a good weld. And then you do it again and again and again, and then the quality is there. And if there's an issue, you can go back and find out and then tweak it, and now the product will have improved itself along the way. So cost, quality, and the fact that there's a job shortage, you need to do that. You need to move in that way.
So I guess that's also driving them, even if they don't want automation, they are forced to go to the robotics because they can't find labor.
Yes, and in the past, the way it was solved, I know this partly from experience, is that one of the projects I was dealing with in the 1990s was Caterpillar in Gosselies in Belgium. And I think it was like right after the Gulf War, and they had like these big orders for lots of equipment to go in and rebuild Kuwait. Decided at that time it would be cheaper to send it over to Poland because the cost of labor there was a lot less. And also the number of welders they needed was there. So in other words, you had this kind of, it's not necessarily offshoring, but it's very similar because it moved from pretty much one country to another. And if you want to start bringing those jobs back, you need to find a way to be able to make sure the production can be done in your local region at a competitive cost. And a lot of times the only way to do that is also by automating more and more and more. And that way your region now starts to become far more competitive to these other regions that might have lower labor rates. And the other thing to remember is that a lot of these regions where the labor rates might be very low doesn't necessarily mean they have the skill level that you might be used to seeing within your own countries. And so a way to be able to grab that, especially before these people retire, is to start having a system that kind of captures, it becomes a knowledge base that's like, this is the way we do a particular type of fillet weld. These are the parameters we use. This is the quality. This is how we want it to look. And then when you come into a sort of a challenging situation, you could ask them like, well, what is the preferred way to do it? I mean, I was always seeing arguments. I never know what it is. It's going to vary. Is that ideally you want a horizontal weld. It's the easiest weld to do.
Yeah.
But there are welds which are vertical. Okay. Which way do you weld? Do you weld from the bottom and go up or from the top and go down? You will get a different answer to that question depending upon who you talk to.
Yeah.
And they will all have their good reasons for why one direction is preferred over another, because it depends on a lot of factors, an absolute lot of factors. So I stay out of that and telling anyone's like, everyone knows you always go down. And it's like, no. There's also a lot of reasons why you would be going up. So those are the kinds of things you need to capture that depends upon your product and how you've successfully been able to weld that product in the past.
Yeah, it's the decades of experience. Yeah, correct. Go on, sorry.
Yeah, it's more art than science. You can look at a weld man and it's like, look, I got all these seams over here, and I'm a robotic programmer, and I'm obsessed about cycle time. So what I want to do is I want to make sure my robot travels the least amount. So I kind of solve it like a traveling salesman problem here and say, okay, if I start over here and I go this seam and that seam and that seam, I do it in that order, I'll be done really, really quick. The problem is the quality of your product will suffer because you just can't weld in any particular order. You have to go through and make sure you weld certain seams first in order to make sure everything is held into place, because you'll have all these stress concentrations and expansion and everything else that's going on. And the expert welder knows that. And he just knows it. You could say, all right, look at this part. What would you do first? And just kind of look at it. There, and there.
Yeah, because he learned from mistakes.
He learned it. And so that's something that's very important to be able to bring along, is like, how do you capture that information to make sure you do it in a particular order? Because as much as we would like to get the cycle time to be as low as possible when we program a robot, in the end, process is king. It's not cycle time. It's like, what's the point of producing all these parts really rapidly if they all end up being scrap? You got to make sure it's done right. So part of that is capturing that, and then the system be able to say, wait a minute, that is the wrong order to be able to go around. You must capture it this way.
Yeah. Good. Maybe going back to one comment you made earlier, because I think that's really important. So it's more about the why now. That why you said that for small and medium-sized companies, why it is critical to go and look for OLP.
It's critical because you don't want your robots sitting 6 months of the year not being used. And it really is. When I was in this project at Caterpillar, they were having these parts that would take 2 to 3 hours to program. That was their cycle time. And they were saying, well, if it's a simple part that's just kind of laying there, it would take them about 50 hours per hour for programming. But if it was on a positioner table that was moving around and the robot was on a track, it'd be really big, then you were looking at more like 100 to 1. Okay, I got 3 hours of cycle time here. Well, that's 300 hours. Okay. There's 168 hours in a week. So assuming you're programming around the clock, you're almost looking at 2 weeks right there. But the reality is we're talking about like a 40-hour week. You start doing the math there and you begin to realize this thing is not there. Now you say, well, what we do is we have 2 shifts. One shift where someone is programming the part, and the next shift where the robot's actually being productive or something like that. So, yeah, but what about set up and set down? If it's a different part, it's probably different fixtures. Everything is organized a little bit different. So you really want to get that thing programmed. You get the whole thing set up. You get the layout up there. You go there. It's going to take you a long time. So you need a way to be able to program it extremely quickly if you are going to be having these small batches that are going to end up meaning that, well, I'm down 6 months of the year. Because what if your run is 10? Okay, it's like, oh, well, within like 30 hours, I've programmed all my parts. 1 week, production is done. How many weeks did it take you to actually create those programs? So that means your batch size is going to have to be very, very, very high. And there are demanding applications out there which you have to do robotically. So if you look at a lot of aerospace type of applications, some of the demands on the quality of those welds is going to be so high, you may have no choice but to do it robotically.
Yeah. Maybe one question we didn't list, but I think it's related to the kind of messages we want to get across, because I am a strong believer that by providing easy access to the tools for the manufacturers for different processes and all the robot brands will speed up the kind of new ideas inside their company that, well, we have a guy who's getting old in the paint shop as well. So what's your view on the development of the other processes than arc welding in terms of the robotic automation?
Okay, yeah. So the arc welding doesn't live in a vacuum. There's all these other processes that beforehand and after that have to be done. And they can also be automated with, sometimes the same branded robot or a very similar robot, just with different end of arm tooling. And so that's very clear. I mean, one of the first things is like, well, the parts have to be cut. So, there's plasma cutting already going on in there. There's similarities between arc welding and plasma because you're basically following a path. So the first thing you have to do is you have to be able to teach a path, and it may be a very simple straight line, or it may be more complex. So the plasma cutting tends to be, let's say, a bit more complex. You have more arcs in there as opposed to arc welding, where everyone considers, the welding to be mostly straight, but that's not always the case. You do have a lot of curvilinear arcs in there as well. So that means you already have the foundation to be able to do it. You just have to fold the process knowledge on top of it. What is the ideal way to be able to cut a particular hole? So you're going to have like an offset in there, a kerf angle you have to deal with. What's the best way to set up your robot, especially if it's a circle you have to do, that you don't wind up the wrist as you go around there, all those things. What's the ideal speed? That would apply to plasma welding. And in arc welding, you've got sort of a similar type of thing. Is what's the attitude of the torch supposed to be to get the ideal weld out of it? What's the proper speed? What's the best direction to be able to moving in and everything else? So those are, again, examples of different process application or knowledge that you would need to have for those things. And then, of course, grinding is something that's going to happen afterwards. After you're done with the weld, we're going to go in, we're going to clean it up a little bit on the part. And then there might be some surface finishing that has to go on there. Now, surface finishing is a little bit different. It's no longer a one-dimensional or, I mean, it's kind of a one-dimensional problem, right? You're just talking about a line. Now you're doing something that's kind of two-dimensional. I like to call it more 2.5D because the part usually has some shape to it, even though it's a surface you're covering at that point. So so that requires a new set of tools, which we've learned over the years because we've leveraged the experience we had. Well, how do you do the 1D problem? Now we've got to take it to the 2D problem. What's the best way to be able to get the coverage and show the coverage and make sure it's adequate coverage and get the prediction in there? So all those processes are out there, and you're going to want to automate more and more and more, and you want to start seeing things more as a production line. As it goes from one process to the next to the next. So it's not just that these things are in isolation over here and then suddenly go, my, our flow is horrible. You know, we need to make sure we kind of coordinate all this stuff and understand that we're using our footprint appropriately, that one process feeds the other kind of naturally. It's very easy to get access to. And of course, the other advantage of having these programs is that you have this really nice archive that's there that you can always refer to. They're all done consistently. They're the same. So if anyone has had to deal with, different programmers working on different things, you see someone else's code and you're like, I don't understand a line of this code because that person has a certain way of being able to write things, or they comment or they don't comment very well. And a lot of times you have to go in and try to figure out what was in that programmer's mind at the time. If you start doing it with an automated tool, all the programs that you generate are going to be consistent and look the same. So someone else has to take over, or someone's on the floor because they have to go in and touch something up. They'll look at the program and they'll know exactly where everything's going to be because it's done with consistent standards throughout the company.
What is your experience? How much the manufacturers love the fact that the technology mix is increasing? So one software for robot brand, all these things that are just going through the roof instead of where we are going to drive it that just one software and you program all the processes, all the brands.
Yeah, I think what drives a lot of people crazy is that you have all these things that are almost the same, but you have a different app for this. So I think the one thing that drives me crazy is when I go to a new city, I need a different parking app to be able to park my car in that city. It's like they all have their own. It's like, oh, why do I have to download this thing and that thing and that thing and that thing? And they all basically do the same thing. Except that it has to be a different application. I have to learn that interface. And we know that drives us crazy. Now imagine the same thing with robots. The robots are all basically doing the same thing, but they have their own language. It's a little bit different. They have their own teach pen with the buttons organized a little bit different. So it's like going from driving a Ford to suddenly driving a BMW or something like that. The stocks are a little bit different. It's like, they do the same thing, but I'm a little bit confused. So a lot of times people will stick with the same brand of robot because they don't like the fact that things are a little bit different in the interface. But not, one brand of robot cannot necessarily fit all the applications that you have in your factory setting. So you're inevitably going to have a mix of these different things, which means everyone has to be a skilled programmer on them. No, it'd be better if you're able to kind of step back and say, we're going to have a neutral way of being able to apply all of them. Now, a lot of the robot manufacturers also have their own sort of OLP packages, which are limited. I mean, they will even admit it's like, yeah, we can kind of program our robots a little bit here. Basically, it's a glorified teach pen. It's a virtual teach pen that you do a few things. But when it really gets down to doing some of the applications, they can't quite do it with the same skill that we can. So we've got a much higher skill set. But at the same time, we can push it out to all the different brands. And in some cases, it's straightforward and very easy. Because, they might have a slightly different syntax for being able to do a particular type of move. So that's like, cut and dry, very, very easy to do. But then there's always a nuance. And we know what it's like translating from one language to another. It might be easier to go between Italian and Spanish because they're very, very similar. But you might lose a little bit of nuance, but it'll be pretty close. But when we go from Italian to Finnish, it doesn't quite work out as well, and then backwards. So you're going to have sort of the same issues going on there that you have to be able to capture that nuance very, very well. And that's something that delphoy has done for years and years, is they realize, in order to do arc welding, you need to do seam searching. But the way you do seam searching in a KUKA robot versus a FANUC robot versus an ABB robot versus a Motoman robot is a little bit different. And so we are aware of the fact that the certain target language that we're going to has this nuance, and we make sure we capture it. So you don't lose the fact that you're so generic, you lose something in translation. The idea is that we know we're programming this brand, but it's going to be similar enough to the operator that they're comfortable with like bringing in this new brand of robot. And that's going to be very important going forward, because we don't want to have, if we've got 5 brands of robots, 5 different offline tools. That's too much. That's too much to manage. You want to really be able to bring it back to one.
Makes sense. What do you think will be the kind of technological evolution or evolutions that will take over in the next 10 years, or that the manufacturing industry will implement because of massive benefits, or will change how they operate? Or...
Okay, so we're going to start to see more and more improvements in the mechanics of the arms. So again, a lot of the robot arms, you look out there, you say, hey, it looks almost the same as like it was in 1980. There's been a lot of refinements and stuff like that and some improvements, but in many cases you can classify them all the same. So, oh, that's an articulated arm, that's a Scara arm, that's a Cartesian arm. And then some others have come along and have changed things up a little bit. So they're slightly different. And especially the cobots that have come out have more unique designs. So going forward, I think we're going to see some more novel kinematic designs and improvements in the hardware that will allow the robots to do things that they couldn't quite do before. Because they are kind of big brutes. You know, they're good at certain applications, but there are others that maybe they're not quite there. But, you know, still having said that, in many ways, the challenges of the mechanics has been solved for quite a long time. What's always been a problem is the software, the brain. And there has been a way to be able to create a program, and the program is flexible. They can make these changes to it, but the way to do it is very tedious, and you have to be in the actual environment that the robot's in there, or capture the environment in some particular way. The question is, going forward, are there going to be better software tools for it? And of course, all we have to do is look around and say, well, what's the hottest product out there right now in the field of computing? And of course, it is AI. And what's going to happen is these robots are going to get smarter and smarter. And eventually, it's probably going to be you almost tell it what you want to do, and it figures it out. So I see that happening. And we are sort of the bridge between that, because do you want to wait 10 years for that to happen? Or do you want to start seeing that productivity already today, which is there, and we're going to start folding in more and more AI tools that it becomes easier and easier. So the way I look at it is that whenever I've had any project, whether it's an offline project, a factory simulation project, and the customer describes the problem to me, in a few minutes, I already know what has to be done. It's already right there in my head. It's very clear what the path forward is. I just have to execute. Yeah. The problem is that execution may take a couple of weeks for me to go through, find all the buttons, poke all the buttons, do everything else, check everything, the results going on. And I'm trying to get the ideas that are in my head into that computer. And then that computer has to demonstrate to me that it was put in correctly. And then it's like, oh, move ahead, move ahead, move ahead. As you start to bring these AI tools in there, it'll be a lot more of just saying, oh, the customer just described the project. Go do it. Yeah. So it's going to be no different than your college professor says, this is what your essay is going to be on. And now you don't have to write the essay anymore. You just come up with a couple of ideas. You tell GPT, hey, write an essay on this. And then you kind of look at it and say, it looks fine, and you're done. So the productivity is going to be there. It may feel a little bit like cheating, but so what? I mean, that's the whole idea, is we're trying to improve the productivity, make things a lot faster. And we have gone from several orders of magnitude already. So like I say, in 1990, it was 100 to 1 on cycle time. And then by about 93, 94, in this project we did with Fincantieri, we had to get it down to 1 to 1 because it didn't make sense. They were building a ship where every weld is the same but different. It was just crazy. It's, it's just like slightly positioned a little bit different, scale a little bit different, because, a ship's hull is curved. And they wanted to implement all these robots. And it's like, either you go in there and the humans do the welding, or the robots. But if the robots are doing it, you have to come up with that program, because that program is used once and once only. Maybe twice if you have a sister ship, but usually that was it. So we had to be down to 1 to 1, or else it was almost useless. Now with delphoy, it's probably a 10th to 1. So maybe even faster. So we may have flipped it from being 100 to 1 to 1 to 100. It could get even faster. It could be that you're talking about 1 to 1,000, or 1 to 1 when you just tell the AI to go ahead and do it. Now, there'll probably be some limits to it because at some point it has to go through and actually test it and run the simulation to make sure the program is actually running right, that there's no issues and kind of resolving all the issues along the way. But it will be pretty much faster than it will take you to throw the thing down there, set it up, run it, remove it, and put the next new part on there. And eventually it'll probably be so smart that you throw the part down there, it'll inspect it with a vision system and figure out automatically how to do the weld. You don't even have to tell it what the welds are. It will know, either from experience, because it goes, oh, this is typically where we do it. And if it's not sure, it'll consult a CAD file somewhere, which maybe indicates where the welds are supposed to be and what the properties of those welds are supposed to be, and then it's done. So yeah, that's going to happen eventually. Whether it happens in the controller or not, I don't know. It may happen in some controllers, but ideally we want to be part of that process, because it may be that brand X over here has it, but brand Y doesn't, and you wish brand Y had it, and say, well, if we have it, both brand X and Y are able to do that now.
Makes perfect sense. So I think we spoke about AI already, but maybe the last question, why do you see the new VCOLP will be addressing the needs of the industry really well?
Oh, because they've needed this for 30 years already. I mean, it's really been a product that, sometimes you have a solution looking for a problem, but we've had a problem looking for a solution for easily 3 or 4 decades. And it's been there, and there have been some clever early adopters out there that have realized the benefits of it and have used it. And the reason why delphoy has been able to do it, because there have been enough people out there that say, this is it. This is absolutely what we need. And this is why it's not a new product. It's a very mature product that is now being marketed very differently to the full world because of the background and experience we've had. So once everyone realized that this is a solution we had been waiting for, and we all know that in our daily lives, we have all sorts of problems around us that we always say, boy, if someone could just solve this, or why doesn't someone do this or that? Okay, well, we finally come in and we've solved that problem for anyone that is thinking of automating, especially if they have anything to do with welding or any of the steps or processes involved in a weld shop. They will be covered, and you will be able to see very early the benefits, and the return on investment will probably be a lot faster than you think. You can be very conservative on the return on investment, and it'll probably turn out that it's faster than you think it was going to be.
Maybe, Scott, can you comment on if we think about design, there is a, let's say, when we've been talking about the geometry, the spatial information within the CAD, but what do you think about the metadata? What can be incorporated within the CAD? I mean, product manufacturing information and utilization of that information when it comes to OLP.
Oh yeah, that will be very important, because in many cases, that's sort of coming from the experience of the programmer that knows what those standards are. But in many cases, when the CAD comes over, it's just 3D geometry, and it's kind of guesswork. Is like, is that a weld joint right there we're supposed to do or not? And what exactly is it? A stitch weld? If it's a fillet weld, is it a 1/4 inch or is it 1/8 inch? What is the information that is not obviously there in the CAD data? So the metadata needs to get folded in to be able to look at that to say, okay, what I can see, this is a multipass weld. So, and now we know what the parameters are that are desired for that to be able to go ahead and program it. Then there's the other aspects of just the CAD design. And a lot of times you come up with what you think is the best design for your fixturing, and you get down the floor and you're like, oh no, it's inaccessible. The robot can't get in there, or we need a different kind of torch or this and that. Wouldn't it have been nice if we had known that ahead of time? It's like, well, you can. By putting it in a virtual world, you can take the CAD design that you have, which is something they didn't do in the 80s, by the way. In the 80s, guys were just out on the floor building this stuff. They didn't have CAD. Now everything is done with CAD. You've got that. You can put it in there and you can say, oh, this fixture is in the way. What happens if I open the fixture? Oh, I get accessibility. can I get by with just opening that fixture if the others are closed? And, some might be able to say, oh yeah, don't worry at that point. Or you can get away with it if maybe we do a few tack welds ahead of time to make sure it's sort of held rigidly in place, and now you can get that. So you can start to experiment and understand whether your setup itself is all right. And you just don't know. I mean, some of these are very complicated, especially when you have a robot on a track and a positioner table. You might be pretty sure you can get into a certain weld, and then you begin to realize there's just no combination of things that will allow me to get in there. I need to know that ahead of time. And it doesn't mean you give up. There are companies that will accept the fact that they can weld maybe 90% of the welds robotically, and they will accept the fact there are going to be a couple of welds that you literally need to have a guy get up there and crawl in to do it, because it's just the only way. Because a human wrist is a little bit smaller than a robotic wrist, and sometimes that one that's like way back in there, that's the only way. So what that means is that the artisan welders are still going to be needed for those really tricky welds. But those long, boring welds, let the machines do that.